Today, we're going to be talking about quotient rule. Here is the general formula. U over V will be V multiplied by the derivative of U minus U multiplied by the derivative of V over V squared. Let's see some examples. Y is equal to x squared plus 1 over x plus 3, wherein U will be x squared plus 1 and V will be x plus 3. Make a table method if you're still a beginner or if you want to. U will be x squared plus 1 and the derivative of U will be 2x. Assign V also will be x plus 3 and dV, which is the derivative of V, is simply 1. Now that you have all the data acquired, you can just plug it into the formula and you will get V will be x plus 3 multiplied by the derivative of U, which will be 2x, minus U, which will be x squared plus 1 multiplied by the derivative of V, which will be 1, over V squared, which will be x plus 3 raised to the power of 2. Simplify this even further and you will get 2x squared plus 6x minus x squared minus 1 over x plus 3 raised to the power of 2. Simplify this even more further and you will get x squared plus 6x minus 1 over x plus 3 raised to the power of 2. That is the answer. Let's try another example. Y is equal to x cubed over 2x squared plus 1. X cubed will be U and 2x squared plus 1 will be V. Now, assign values once again. U will be x cubed. Derivative of x cubed will be 3x squared. Now, V will be 2x squared plus 1. Derivative of V will be 4x. Assign all values according to the formula. You will get 2x squared plus 1 multiplied by derivative of U, which will be 3x squared minus U, which is x cubed, multiplied by derivative of V, which is 4x over V squared, which will be 2x squared plus 1 raised to the power of 2. Simplify this, you will get 6x raised to the power of 4 plus 3x squared minus 4x raised to the power of 4 over 2x squared plus 1 raised to the power of 2. Simplify this even more further and you will get 2x raised to the power of 4 plus 3x squared over 2x squared plus 1 raised to the power of 2. Now, let's try to solve some trigonometric problems using quotient rule. Y equals sine of x over x. Now, as usual, sine of x will be U and x will be V. Assign the values here. U will be sine of x. Derivative of sine of x will be cosine of x. V will be x and derivative of x will be 1. Solve it according to the formula and you will get x multiplied by the derivative of U, which will be cosine of x, minus U, which will be sine of x, multiplied by the derivative of V, which will be 1, over V squared, which will be x raised to the power of 2. Simplify this, you will get x cosine of x minus sine of x divided by x squared. Let's try another trigonometry example. Y is equal to tan of x over cosine of x. U will be tangent of x, and the derivative of tangent of x is secant squared x. V will be cosine of x, and derivative of v will be negative sine of x. Now solve this, you will get cosine of x multiplied by du, which is secant squared x, minus u, which is tan x, multiplied by dv, which is negative sine of x, over v squared, which will be cosine squared x. Simplify this, you will get cosine of x secant squared x plus, because there's both negative, tangent of x sine of x over cosine squared x. Let's try some exponential functions using product rule. Y is equal to e raised to the power of x over x squared. No? U here will be e raised to the power of x, and derivative of e raised to the power of x is simply e raised to the power of x. It does not affect it. V will be x squared, and derivative of x squared will be 2x. Plug this into the formula, you will get x squared multiplied by e raised to the power of x minus e raised to the power of x multiplied by dv, which is 2x, over v squared, which will be x squared raised to the power of 2. Simplify this, you will get x squared e raised to the power of x minus 2x e raised to the power of x over x raised to the power of 4. Let's try another example. Y is equal to x over e raised to the power of x. U here will be x, derivative of x will be 1. V will be e raised to the power of x, and derivative of e raised to the power of x is still e raised to the power of x. So the answer will be e raised to the power of x multiplied by 1 minus u, which is x, multiplied by derivative of v, which will be e raised to the power of x, over v squared, which will be e raised to the power of x raised to the power of 2. Simplify this, you will get e raised to the power of x minus x multiplied by e raised to the power of x over e raised to the power of x multiply raised to the power of 2. Now, let's try solving logarithmic problems using quotient rule. Y is equal to ln of x over x. U here will be ln of x, and the derivative of ln of x is 1 over x. The formula for finding derivatives of natural logarithms is as follows. Ln of u is equal to u prime over u, or du over u. And since our u here is x, the derivative of x is 1. So it will be 1 over x. Now, v here will be x, and derivative of v, which is x, is 1. Let's plug that into the formula and we will get x multiplied by du, which is 1 over x, minus u, which will be ln of x multiplied by derivative of v, which is 1, over v squared, which will be x raised to the power of 2. Simplify this even further, you will get x minus ln of x over x cube, because 1 over x, just put x below. No? Let's see one more example of logarithmic function. Y is equal to 1 over ln of x. No, u here will be 1, and derivative of any constant is 0. Now, v here will be ln of x, and derivative of ln of x will be 1 over x. Plug this into the formula, you will get ln of x multiplied by the derivative of u, which will be 0, minus u, which will be 1 multiplied by the derivative of v, which will be 1 over x, over v squared, which will be ln of x squared. Simplify this, you will get negative 1 over 1 of x over ln of x raised to the power of 2. Simplify this even more further and you will get negative 1 over x ln of x raised to the power of 2. Now, let's try to challenge ourselves. Y is equal to e raised to the power of x over ln of x. This is mixed exponential and logarithmic. Now, let u here be e raised to the power of x, and derivative of e raised to the power of x is still e raised to the power of x. V here, which is ln of x. Derivative of ln of x is 1 over x. Solving this, we will get ln of x multiplied by e raised to the power of x minus e raised to the power of x multiplied by 1 over x over v squared, which is ln x squared. Simplify this, we will get ln of x of e raised to the power of x minus e raised to the power of x over x multiplied by ln squared of x. Y will be ln of x over x squared plus e raised to the power of x. U here will be ln of x, and derivative of u will be 1 over x. V here will be x squared plus e raised to the power of x. Derivative of v here will be 2x plus e raised to the power of x. Now, let's solve this. It will be x squared plus e raised to the power of x multiplied by 1 over x minus ln of x multiplied by 2x plus e raised to the power of x divided by v squared, which will be x squared plus e raised to the power of x raised to the power of 2. Simplify this even further, and you will get x squared plus e raised to the power of x minus 2x ln of x minus e raised to the power of x ln of x over x multiplied by x squared plus e raised to the power of x raised to the power of 2. Simplify this even further if you want, but I will leave as it is. This will be the last problem of this video. Y equals tangent of x over x raised to the power of 2. U here is tangent of x, and derivative of tangent of x is secant squared of x. V here will be x squared, and derivative of v will be 2x. Plug this in the formula. You will get x squared multiplied by secant squared x minus tangent of x multiplied by 2x over v squared, which will be x squared raised to the power of 2. Simplify this, you will get x squared secant squared x minus 2x tangent of x over x raised to the power 4. Simplify this further if you want, but I will leave this as it is.